So now, after all that craziness, right, of learning this new thing, now we're just going to, I think actually doing logarithms and evaluating them starts to help you see what they mean. So my first one says log base 2 of 8. So this means what exponent with a base of 2 gives me 8. So that answer would just be 3, right? 2 to the third equals 8. The exponent is the answer. And if you wanted to check it, or if you wanted to solve it this way, I kind of encourage my students to, with the simple ones, just to kind of like figure them out in their head, make sure they understand it. The base is 2, the exponent is 3, and the number is 8. So this is Benny form, log Benny, base, number, exponent. And if I write it in exponential form, Ben, base, exponent, number, that does make sense, and I can tell that I have the correct answer. This is not the answer is 3. Okay, that's also important to understand. Logs equal exponents. Exponents are the answers. So the next one, what exponent with a base of 4 gives me 16? That would be 2, right? Because 4 squared is 16. You can definitely go and try a couple. What exponent, but you can come back and check. What exponent with a base of 5 gives me 625? That's 5 to the 4th. What exponent for 10 gives me 100,000? There's 5 zeros, so that's 5. And we can also do it with negative exponents. So what exponent for 2 gives me 1 over 64? Usually here I just think about the 64. So that would be 2 to the 6th. But since I have division, I have fraction, I need an exponent of negative 6. And just to check, remember this is log base number equals exponent. So if I put it in Ben, base is 2, exponent is negative 6, I can say, yeah, that makes sense. 2 to the negative 6 equals 1 over 64. Remembering that negative 6 is still my answer. What exponent for 3 gives me 1? Well, what exponent for anything gives me 1? That exponent will be 0. Next one, what exponent for 5 gives me 1 over 25? It's negative 2. This is not on our chart to memorize, so you may or may not know this one. But basically, if you're not sure, you know this is kind of like a no calculator section. This is without the use, if possible, without the use of your calculator. So if you need to, you can go to your calculator. You know it's going to be some sort of integer. So I would try, I know 7 squared is 49. 7 cubed is actually 343. So this would be negative 3 because of the division. Moving down, we have a row that's a little bit more challenging down here. It says log base 4 of 2. So you might be able to figure this one out, but if you're ever stuck, you can always put it in exponential form and think about it, or do common bases. So this is 4 to the x equals 2. Maybe you see it then. If you still don't, you can make common bases. So 4 is 2 squared. 2 is 2 to the first. So I'm just rewriting with common bases like the last lesson. Canceling, I get 2x equals 1. So x equals 1/2. Okay, so this answer is 1/2. Now, I think it's just way easier to think, oh, I need to take a square root of 4 to get a 2. The exponent for that is 1/2. If you see that, that's faster than solving the whole equation. The next one's a little trickier, and you can do these in your head. Definitely one you might want to try common bases. I'm going to show this one in your head just so you can think about it. So 4 and 8, like 8 is not a power of 4, but if I take 4 and I square root it, that would give me 2. And then 2 cubed is 8. So that's just using a fractional exponent. 4 to the 3/2, square root of 4 cubed is 8. The next one we can just kind of see. What exponent for 5 gives me the square root of 5? Right, we know square root is equal to the 1/2 exponent. And just to check that one, 5 to the 1/2 base to the exponent does equal the square root of 5. So you can check and see. The next one, I need to go from 3 to 9. But it's the 5th root of 9, so the root is 5, and the exponent to get from 3 to 9 is 2, okay? And that's because if I take the 5th root of 3 and square it, that's going to be the 5th root of 9. The next one is not one we can do in our head. We have between which two consecutive integers does log base 3 of 40 lie? So we can't know in our heads exactly what log base 3 of 40 is, but I know log base 3 of 27 is 3, right? Because 3 cubed is 27. And log base 3 of 81 is 4. So if I look at 40, since 40 lies between 27 and 81, the exponent for 3 that I need to get to 40 has to be between 3 and 4. So here's another one. It says, between which two consecutive integers must the value of log base 4 of 7,342 lie? Now, this is 7,342 is definitely bigger than any powers of 4 that you're asked to know. The biggest one you need to know is 4 to the 5th is 1,024. But you can kind of, use your calculator, try to figure it out. 4 to the 6th is 4,096, and 4 to the 7th, this is just off your calculator, or if you happen to know these off the top of your head. So this 7,342 is between these two numbers, between 6 and 7. 7,342 is between 4,096 and 16,384. So log base 4 of 7,342 is between 6 and 7. In terms of justifying your answer, this is fine for justifying your answer. Here we have a couple equations that are starting in log form. So before we had more evaluations of logs, when we have equations that are in log form, we're just going to change them over to exponential form and then solve from there. So here on each of these, you want to think about the fact that this is base number exponent, and we want to go to base exponent number without the log. So this is 4 is the base, 5 is the exponent equals x. This is just one to evaluate. So that's 1,024 equals x. The next one, base is x, exponent is 3, and that's 216. Now here you might just know the answer from the facts that you know. If you wanted to solve it, you could take a cube root, or you could raise it to the 1/3 power, which you can do in your calculator. So I'm going to use this method. That will just cancel out this exponent. Same thing as the cube root, 1/3 power. If I type that in my calculator, if I'm not sure, that would equal 6, because the cube root of 216 is 6. The next one, I have 5 to the x equals 625. I probably just know what the answer is from my facts, but if I wanted to, this one is one where I'm trying to find the exponent, so I could make common bases, cancel the common bases, and we get x equals 4. Looking through the rest of them, this is x to the negative 2 equals 1/36. I know that's 6, right? 6 squared is 36. 6 to the negative 2 would be 1/36, but I could use that reciprocal exponent rule, so this is going to cancel that exponent. I could type that in my calculator. I could also know that's going to, flip the fraction because of the negative exponent, and then it's going to take a square root, so that's going to be 6 for this answer. Looking at the next one, we have x to the negative 2/3 equals 1/25. I'm going to show this one by hand. So this is negative 3/2, reciprocal exponent to cancel it out. So I have the square root of 1/25 to the negative 1/3, right? So this is square root negative 1/3. So that's 1/5 to the negative 1/3. Flip the fraction, right? It's not going to be division anymore, so that's 1/25. And when you're solving these equations, it is totally fine to do these in the calculator. The next one is relatively easier. Base is 64, exponent is 1/2. 64 to the 1/2 just means the square root of 64, right? So this answer is going to be 8. The packet is a little messed up right here. So exercise 7, and if you're watching this in the future, I will have fixed this. Exercise 7 is kind of smashed in here. It says, between what two consecutive integers must the value of log base 5 of 1 over 500 lie, justify your answer. So I'm actually going to make a section over here, and we'll do the work right here. So this one is another one where we don't know the log base 5 of 1 over 500 because 500 is not a power of 5. But we could answer these two, 1 over 125 and 1 over 625. Those are both powers of 5, we know. So this one would equal -3. This one would equal -4. So it's going to be between these two numbers. The last little thing in this lesson is just a fact. Just like a lot of things in math, like when we write x, we don't write 1x. When we write the square root, we don't write the little 2 right here. And basically those things are just because they're implied. So square roots come up all the time. So we don't have to write them. We don't have to write the little 2 because we decided that when we don't see the 2, we're going to know the 2's there. So with logarithms, one of the really common logarithms, and we actually call it the common log, is a log with a base 10. It goes well with scientific notation, powers of 10 that you've seen in science. So basically, if I just see the word log of x, I assume or know there's a 10 there. So for example, when I see log of 100, I know that's really log base 10 of 100. 10 to the second equals 100, so that would be 2. This also is base 10, so 10 to the -3 would give me 1 over 1,000, that's 3 zeros. This one, 10 to the what equals the square root of 10, that's the 1/2 power. So anytime log does not have a base, the base is 10.